Hello everyone, good morning and welcome to our online science class. Kindly prepare your materials with you. If you don't have them, click the pause button and get your course book, your pen and notes. We're gonna have an exciting topic for today. But if you have them, let's go. We're gonna have a bit of recall of our topic last time, and that is all about distance time graph, and I hope that you can still remember them. But if you don't, we're gonna refresh your mind about that, alright? So let's think about this. The graph that is shown right over there is a distance time information of, let's say, an airplane that you are riding. So based on that, let's see, you have seen it on the monitor. How would you think the airplane you're riding at right now travels? Could you please give me some words? I want to hear it. Let's see. If you say that it's in a steady speed, or it is running, it's flying steadily, or running steadily if it's in a runway, or it increases its speed steadily. So if the line here shows like this, it's a straight line, and it is diagonal as shown there in the graph, that means that the speed of the airplane is increasing steadily. So let's say if it's running for 10 meters per second, well, that's a little bit slow. Let's say it's 100 meters per second. So all throughout the time here, it's running at a constant speed and it's steady. That means that it has the same speed all throughout the duration of the distance where it's traveling to. It's 100 meters per second all throughout. So if you see this graph, it shows that something or a moving object is increasing its speed steadily. Let's take a look with the second slide in here. So let's say you are watching the F1 race here in Bahrain, and the graph on the television shows that one. It's a red car versus the blue car. So based on that alone, how will you know which of the two cars won the competition? So could you please let me know some words in your mind that allows you to tell that which of the two won in the competition? Is it the red car or the blue car, and why? So let's see if your words matches with words I have here. So it's the red car which actually won. So the question here is why? The red car is faster, but what makes you think that the red car is faster? Look at the slope. We call this the slope, the line right over here. It's more steep, or it's steeper compared to the blue car. So if it's steeper, this shows that it travels on a farther distance, because the distance here has a higher demarcation compared to that of the blue car, over at the same period of time. So more distance over that period of time, it shows that it can travel a longer distance over a given period of time. That shows that the red car is faster compared to the blue car. And of course, if you look at the slope of the blue car, it's sloping a little bit downward. It shows that it has less distance in comparison with the red car over a period of time. This shows that the blue car is slower and the red car is the winner. Did you get it also correctly? That's awesome. Let's proceed with the next graph right over here. So let's say that you are in a car and you are riding it, and you have noticed that the graph is shown in the road speed camera. So how does your car run? What is in your mind? Okay, I think that you have also an answer in mind, but let's take a look here with the words that I have here. So if the graph shows like this, it shows that the car that you are riding at is speeding up. What makes me say that it's speeding up? Look at the curve in here. It might not be running steadily because you tend to have a change here in the distance and in the time traveled over a period of, let's say, a time or traveled, or which part of the graph that you want to identify the speed here. So the curve here shows that it is speeding up, it is running, and it is increasing its speed every time or over time that is traveled, because it tends to increase its distance. So if the graph shows a little bit like curved like this. We call this parabolic. So this shows that the car is speeding up. All right. So I think I think you know much about these three graphs that I have shown here. So this time, let's test your knowledge. If you need more time to review those three graphs that I have, kindly hit the pause button right now and review them. But if you're ready, let's go. This is question number 1, and each of that is 1 mark each. Okay, so this is question number 1. Which of the graph here shows that a moving object is speeding up? Is it A, B, C, D, or E? Let me check your answer. If your answer is B, you are correct. That's 1 mark. Let's take a look with the second question. Which of the graph here shows that a moving object is at rest? Which do you think? Let's compare it with the answer that I have here. It's definitely letter C. Why letter C? Because it stopped at a distance of 100 meters and the time is still increasing. That shows that the moving object is not moving at all because it stopped at a distance of 100 meters and it just remains steady there, taking some rest. Alright, so let's take a look with number 3 question. Which of the 5 graphs here shows slowing down? Do you have the answer? Let's see. The correct answer is it's letter D. You look at letter D here. The graph here shows that the distance is decreasing as the time is increasing. It shows that it's not going faster, it's going slower. This means that this graph here, it shows that the moving object is actually slowing down. Question number 4. Which of the 5 graphs here shows steady speed? Think. Let's take a look. The correct answer is it's letter A. So I want you to take a look with the trends here of the graph. And it's gonna be helpful someday if you're gonna be a driver, if you're gonna look at the news and gonna take a look with the graph. It's gonna let you know if you're speeding up, slowing down, or just taking a rest, or which of the 2 cars there, or which of the 2 moving object is faster than the other. Alright, so I hope that you get 4 marks. So if you get 4 marks, kindly write your mark on the comment section below. I want to know it. And you're doing great. I know. So let's take a look now with our topic for today. So I'm gonna give you another mind-boggling questions here, and I hope that you are really familiar with all the things we're gonna throw up in this screen. So here's another quiz. Quizzes here never ends. So let's take a look with the first question. This is question number 1. Please write your answer on the chat box or in the comment section. Name this musical instrument. Let's see if you get it correctly. It's the French horn. Just look at how it looks like. Next question, number 2. Name this musical instrument. I'm gonna give you a clue. This is a traditional Arabic musical instrument. Hope that you will know what it is. Let's see, this one is called the ney or the koala. Well, nice name. And it looks like a flute anyway. Okay, this is question number 3. This is a very famous musical instrument, and what is the name of this? Let's see if you get it correctly. It's very famous in Europe. It's the bagpipe, and I love the sound of the bagpipe. Next question. Name this musical instrument. I saw this a lot of time in South American nations, and it's the maracas. Next question. This will be the last. This is also a traditional Arabic musical instrument, and I hope that you know this. Let's see. This is called the canon. So, how many marks did you get? Did you get all 5 questions? Did you get it all 5? That is awesome. So, what do you think is our topic for today? It's unrelated to our previous 3 questions there about the graphs. So, what do you think? Exactly. Our topic for today is all about sound. So, it's all about changing sounds. And open your Coursebook on page 136 to 137 for your reference. So today we're gonna learn what is the difference between loudness and pitch, and I think that you're really familiar with what loudness is. And let's focus ourselves with what is a pitch, and let's differentiate what pitch and what loudness is. And we're going to determine here the factors that affects loudness and pitch, and how to identify if a sound is loud and if a sound is soft or a sound has which pitch. Okay, so observe how these instruments are played right over there. I have A, B, C, D, E, and F instruments. So I want you to suggest on ways on how to group them together. So we have all in all 6 instruments there. So please think. Do you have an idea in mind now? So let's compare it with what I have here. So I have grouped them on how they are played. So in group 1, there are strings in there. So technically we call this kind of instruments as the stringed instruments. On group number 2, since we blow it, we use air to play it. So I grouped them together, and thus the name of these instruments are the wind instruments. And for the group number 3, since you need to tap on it or to struck in it, so I grouped them together, and this one is called the percussion. So basically, there are 3 kinds of musical instruments. It's a string instrument, we have the wind instruments, and we have the percussion. Can you give more examples of those? I want to hear. That is awesome. So I know that you're really familiar with what are these musical instruments. So the question here is how sounds are produced from these musical instruments. Okay, I want you to take a look with the video that I have right over here. It's the guitar, and let's try to see how sounds are produced from a musical instrument. So kindly turn on your volume right now, louder, so that you can hear it. So the person here is strumming the guitar. So take a look and observe on what is happening to the strings of the guitar. This one has been videoed in a slow motion to see what is happening to the strings of the guitar when someone is playing in it. So to produce a sound for all the musical instrument, not only for string instrument, there should be something that is moving. So a part of the musical instrument tends to move here. In the case of the wind instrument here, it might not be seen, but there's a mechanism inside of it that tends to move. And those motions are very obvious to the string instrument and to the percussion instruments right over there. So what causes sound to be produced in this musical instrument? Exactly, there should be a movement, and we call that movement as vibration. So what is a vibration? So to better see what vibration really is, I have here an experiment about the tuning fork, and the tuning fork was strummed and it tends to move, and that movement again is called vibration. We put that on the glass with water and try to see what happens to the glass to the water on the glass. It has been videoed on a slow motion. And try to observe what happens to the water particles now. Exactly, the water particles tends to move, and it's splashing right over there. So the splashing of the water here shows that the tuning fork is actually moving, and you can hear the sound. So if we have a laboratory, we are actually gonna do that. So what vibration is doing here is it creates the sound, and it travels all throughout the air and it reaches your ears. So what is vibration? So technically, vibration is just the motion of the particles of a matter that causes now sound to be produced. So we have here two. So first type or mechanism of sound or dimension of the sound we're going to explore is loudness. I want you to put your laptop or your gadget or your phone right now into full volume, and you would hear loudness. This is a drum strumming. And look at what will happen if I manipulate this. So the sound, what happens to the sound? So what have you observed with the sound? Exactly, so when I turn on the volume or I turn the volume up, the loudness becomes higher. It becomes too loud. If I put the volume a little bit lower, the volume or the sound becomes softer. So we call that loudness. So what is loudness? I want you to focus yourself on this A and B here. So if, for example, we put a string on it, or we measure it in a device which will measure its sound waves. So we call this now your sound waves. Again, I'm gonna play it again. So we call that sound waves. Notice the difference between the sound waves of A and B. Okay, I'm gonna pause those two videos. Look at the sound waves. So the height here is called the amplitude. So that speaks about the height of the wave over here. So look at, this is the amplitude, and this is the amplitude of the sound waves. So notice that on the amplitude of the sound waves in A, it tends to be higher. On letter B, it's a little bit lower. So which of the two here you think it speaks about loud? Is it A or B? If you answered A, let's see. Okay, A speaks here that the sound is loud. How about on letter B? Exactly, it's the opposite of loud, so it is soft. So the soft sound is produced if you have a lower amplitude, and a loud sound if you have a higher amplitude. So when you say loudness, what do you mean by that? So loudness is often used to describe the volume level of a music or a sound. So it talks here about this one, which has a higher amplitude, and this one, which tends to have a lower amplitude. So we have their loud and soft. So let's take a look with another dimension of sound. So at this time, if you're using your headset, kindly remove that because we need to protect your ears, and put your volume a little bit down, probably on level 70 or a level 7. So please be careful about this. I just want to show you here another dimension of sound. So I want you to listen here. We call this the pitch. So listen carefully on what will happen in here. Take note of the quality of the sound. What can you say about it? It's a little bit painful to the ears, that is right, and it's a little bit high. It's a high sound, that's good. But let's continue. And it turns higher and higher as time goes by. And it becomes highest until it becomes inaudible. That means you can't hear it anymore. So this refers about the pitch of a sound. So what is a pitch? I want you to take a look here with the sound waves produced by A and B. Notice the amplitude. What can you say about the amplitude in letter A? What can you say about the amplitude on letter B? I'm going to repeat the video again. Look at what can you say about the amplitude of letter B? Exactly, look at the difference. This one is more frequent. The amplitude is more frequent. It shows here frequently for every second. And how about for letter B? If you take a look with it, the amplitude tends to be wider, and the amplitude is spread out compared to this one. So I'm gonna pause it so that you can see it clearly and vividly. So which of these two here you think that the pitch is really high? It's like what you have heard a while ago. Is it A or B? If you answered A, you are correct. So if it's a high pitch, that means that the amplitude tends to be more frequent. Thus, each of these waves tends to be shorter or tends to be closer with each other, and that gives the sound the quality of having a high pitch. However, if the sound waves here are spread out compared to this one, it shows that it has a lower pitch than letter A. So what now is a pitch? So pitch is, it talks about having a high or low note. That's why you can hear it that way. It's a really high note, and sometimes it becomes very painful to the ears. And lower note if it is good for the ears. So we have two things, two dimensions of the sound that we have learned for today. We have loudness and we have pitch. Can you recall those two? What is loudness? That is great. Loudness talks about volume up or down of a sound. And how about pitch? You can see that there at the top. Pitch is when you can make the note higher or lower, thus you can now change the pitch. So if you want to review the difference between loudness and pitch, you can go back to the previous slides. You can rewind this video. However, if you are ready and you know about those pitch and the loudness, let's test how much you've learned so far. So we're gonna give you here an example of sound waves, and you need to identify if it is a loud loud, it's a soft sound, it's a high-pitched sound, or a low-pitched sound. So write the word which is described by each item below and 1 mark for each. Question number 1. Look at this. Do you have the answer? Let's see. It's high pitch. Are you correct? That's awesome. Let's take a look with letter B. Letter B is, it shows a low pitch sound. This one is more frequent. The amplitude the waves tends to be more frequent. It's shorter and it's closer with each other. And B, it's farther from each other. Let's take a look with letter C. What is being shown in here? So what is shown here is just vibration. So you can see that there's a motion of the water made by the vibration of the tuning. Excellent job. Next, look at this. Let's see your answer. It's the loud sound. Why is it a loud sound? Because this tends to have a higher amplitude. Thus, we have the loud sound. And let's take a look with letter E. If you look in letter E in comparison to letter D, this one has a lower amplitude compared to letter D. So definitely this one is a soft sound. So did you get all the 5 questions correctly? If you get all 5, kindly put it on the chat box or the job well done. So do you have questions or clarification about our topic? Don't hesitate to message me. So I'm going to post the worksheet tomorrow, and that is every Wednesday. So if you don't have any question, that will be all for today. Goodbye.